The seamless bridge concept, originally proposed in Australia, eliminates expansion joints between the bridge and the pavement. Continuously reinforced concrete pavement, or CRCP, is used to create a transition zone between the bridge deck and the CRCP to reduce long-term maintenance costs and improve durability of the bridge. The Center for Transportation Research recently completed a study on the performance and design of seamless bridge CRCP systems to closely analyze the behavior of seamless bridge pavement systems and propose general design recommendations for practical applications in the U.S.
The traveling public probably notices this. If you go over a bridge in January when it's 20 degrees, there'll be kind of a little bit louder bump, and that's because the bridge joint is opened up a little bit. But also that joint allows a lot of corrosion-causing agents to actually pass from the bridge deck down into the girders and substructural elements, leading potentially to corrosion issues, locking up of the joints and the bearings. They end up kind of impacting the long-term behavior.
If we can develop a bridge that is jointless, in fact, we have solved major percentage, we have eliminated the major cause of corrosion in bridges.
The goal was to try to look at the viability of using the seamless technology here, and then to try to develop a bond-breaking element that you could put between the embankment, the foundation elements of the embankment, and that slab that you're extending that allows the concrete slab then to expand and contract. We started off by evaluating various bond breakers in a smaller test setup to try to look at, we could cast the concrete, it would prevent the concrete from bonding then with the base material that we have. And then we would subject that to some shearing and get a measurement of the coefficient of friction. So we did kind of find, we think, the bond breaker that we would need from that. And then we've also developed a pretty comprehensive design methodology.
What has been done now is the laboratory study. So the next phase is to do an actual implementation of this research on an actual bridge. With implementation, we'll be able to monitor the performance and correlate the field study with the laboratory result that we have collected.
We think it'll improve the ride quality on the bridge, but also long-term maintenance issues. The cost of maintaining that bridge long-term will be reduced. So there's we think, good viability on a wide range of Texas bridges where this might provide a very good solution.
For more information and to find the publications for this project, please visit the TxDOT Research Library at the link shown below.